All right, so the challenge was to modify the implementation of merge sort so that it sorts the integers in descending order. And this is the start project that was in the resources section. So if we just go ahead and run right now, we'll see that the merge sort is sorting in ascending order because this is essentially the code that we did in the merge sort video. We want descending order. So let's go ahead and look at the code. Now the splitting phase doesn't have to change. I mean, all the splitting phase does is keeps dividing the array into two. It doesn't care whether you're sorting in ascending or descending order. So we don't need to change the merge sort method at all. What we have to change is the merge step, because that's the step when we're comparing elements in the right and left arrays against each other and writing them in sorted order to a temporary array. So when we're doing that, instead of sorting them into ascending order, we want to sort them into descending order. So there are two places that we have to change in this merge method. The first place is this optimization. In the merge sort video, we went through what this optimization is doing. It's essentially checking to see whether you actually have to do any merging, because if this condition is true when we're sorting in ascending order, then it means that all the elements in the left array are less than all the elements in the right array. And because the left array and right array are in sorted order, it would mean that if we copied them to a temporary array, we just end up copying the temporary array back into the input array, and none of the elements, the positions of none of the elements would change. And so this optimization avoids needless work, but if we're sorting in descending order, this no longer makes sense. What we want to know now is whether all of the elements in the left array are greater or equal to all of the elements in the right array. Because if that's the case, then we don't have to do any work. So our first change here is going to be greater than or equal. And so if all the elements in the left array are greater than or equal than all of the elements in the right array, we don't actually have to do any merging. If we were to merge them, we just end up sticking the right array on to the end of the left array, and then we'd have that entire range of elements sorted in descending order. Now the second place we have to change is when we're actually doing a merge and we're traversing the left and right partitions and we're comparing elements in the left array against elements in the right array. So here we're saying that if the element in the left array is less than or equal to the element in the right array, then we write the element in the left array to the temp array. Obviously, if we're going to be sorting in descending order, we want to write the larger of the two elements into the temp array first, not the smaller of the two elements. And so once again, we're going to change that to greater and equal to. Now, keeping this equals is extremely important because merge sort is supposed to be a stable sort. And so if we have the situation where the element in the left array is equal to 5 and the element in the right array is equal to 5, we want the one in the left array to be written first because that will preserve the relative ordering of the duplicates. And so we want an equals here. If this was just greater than, it would result in the element in the right array being written before the one in the left array, and that would turn merge sort into an unstable sort, and we don't want that. And that's it. That's all we have to do to change this implementation to sort the integers in descending order. So let's run. And there you go. 55, 35, 27, 1, minus 15, and minus 22. So that was a rather easy one just to get us warmed up. All right, so let's move on to challenge number 2.